Hello, Homework 101, Metamorphic Rock Coloring, Mr. Gazda here. Let's do this. Color is directed below. Make sure you're familiar with the Know It information, as there may be a quiz on this material in class. There will be a quiz. I'm telling you now. So here's the chart. This is the Know It stuff. Here we go. Know It. Metamorphic rocks form when an existing rock gets buried under miles of other rock. The weight of all the rock on top of it puts a lot of pressure on the rock. It also makes the rock very hot, causing it to partially melt. Okay. Key thing here is partial melting. So if it was to completely melt, it would become magma again, and then form an igneous rock. It's the partial melting. It gets like a weird material, kind of like maybe like a peanut butter consistency. That's probably a good comparison. Peanut butter. That's key. So know that. Know it. The pressure on the rock causes flat layers in metamorphic rocks. This layering is called foliation. Draw boxes around the rock name for each foliated rock. The boxes should be in red. So foliation, if you have pressure on a rock going downward this way, you're going to have flat layers of all the minerals will be really flattened in this way. So let me show you some examples of foliation right here. So this rock here, if you can look at the side, let me see. I don't know how well that comes through. See those little layers like this? They all run this way. Like pages of a book, basically. So, in this case, that means the pressure was coming down this way on it, and it flattened those layers that way. Oh wait, no, this side even shows it better. We get the light on there, right? You kind of really see it right there. The foliation of those flat layers. Notice they're all the same color. Pressure pushing down on it this way. And we saw foliation also in that in the take-home rock homework as well. Here's another type of foliation. Hopefully you can see it. Light may not be great. Again, foliation this way. Alright, like really thin layers. That's foliation. You can see them right there. So that means it was, again, the pressure was pushing down on it this way, and all the layers got flattened perpendicular to it. And those are probably the two best examples I have of foliation here. So that's key. It's called foliation. They're layers of the same color. We're going to draw boxes around the rock name for each foliated rock. And it's going to be in red. Is this red? Yeah, so here's red right here. And here's texture, foliated versus non-foliated. All these rocks are foliated, so I'm coloring the boxes around. Draw boxes around the rock name for each foliated rock. Gneiss, schist, phyllite, and slate are all foliated metamorphic rocks. 3. It says here, so you start out with a rock. It gets buried, a lot of pressure, very hot. It can become a metamorphic rock. But the rock it starts out with is the parent rock. The parent rock is the original rock that exists before it was changed by heat and pressure. Okay, so to talk about that a little bit, here what I have is, if I have the, no, not there, hold on, this sedimentary rock is sandstone. I'm not sure if you see the little sand grains here, but if you saw this in person, you would see a lot of sand grains. We saw this during sedimentary rock lab. Now, if this was to get buried and partially melted, so the crystals, so the sand grains will kind of melt together, you will end up with this. The metamorphic rock would be called quartzite, and it was partially melted. But it's a metamorphic rock, and in this case, it started out as this. This is the parent rock. In this case, it is sandstone, and then the metamorphic rock would be quartzite. So that's the key part of what we mean by parent rock. Find the metamorphic rock that is a parent rock of sandstone. Oh, I just talked about that one. Lightly color the entire horizontal row for this purple. So you would look right here. Where does it say that? Metamorphism of quartz sandstone. And sandstone, that's what it is. It's all quartz sandstone. And the whole horizontal row, purple, I would do it like this. This is purple. And I don't care if you go over here. It's not really about coloring. It's about just understanding how this works. The coloring just helps. Know it. Some metamorphic rocks do not have foliation or layers. These are called non-foliated metamorphic rocks. Okay, non-foliated. Color the entire horizontal row for each foliated metamorphic rock yellow. Okay, so all of these are non-foliated. So if you were to color them yellow, the entire horizontal row, is that what it says? Yeah, so it's basically this, all of these are non-foliated, so you just kind of color, all of this gets colored yellow. And you color right over the purple, that's fine. You can color this, it doesn't really matter. Okay, non-foliated, here's some examples of we'll go back to this. Non-foliated, don't see any layers here. Okay. This is quartzite. Another non-foliated metamorphic rock is, this is a type of marble, and maybe you can see, but there's no layers, it's just like one big sort of consistent rock throughout. Some metamorphic rocks look like this. A little hard to tell they're metamorphic. We tend to focus on the ones that have some sort of foliation. On to the back. This is a lot right here, but this is very important. Watch this. Okay? I have an example here. Banding, distorted banding. When a metamorphic rock is partially melted, it can have the consistency of very thick toothpaste. I also said it maybe even a better example is like peanut butter consistency. Okay, it's a little hard, you know, we've never really seen it really in the real world, but we know that to be something like that. When a rock is like this, the minerals in the rock will may slowly move in this peanut buttery-like rock. When they move, called migrate, minerals of the same type tend to group together. Example, quartz groups with quartz, mica groups with mica, etc. This causes layers of different minerals within the rock. You can see these in the rock as layers of different colors. See the diagram to the right, like this, banding, like these sort of striped patterns. These colored layers are called banding. Lightly color the horizontal row of the rock with banding green. Okay, where we see that. Where does it say banding? Banding is right under texture. Banding is here. So it's a type of foliation, because there is layers, but it's colored layering. So we're coloring the whole thing, whatever, the whole horizontal row, we're coloring it green. And that rock is gneiss. It's pronounced nice. There's a silent G at the beginning of it. There you go. Okay? That's key. Banding is key. Banding is key. These pictures here are key as well. Distorted banding, so they can kind of get wavy looking. Let me see what I have here for banding. Any sort of like stripes, you can kind of see them here. You see the different stripes, they're like the black layers that go throughout. Okay, that's a good example of banding. You can see it here pretty well. All the banding goes like this. It means the pressure was coming down on it this way. So that's a pretty good example of banding. Let me get another example of banding. This one's pretty good. Yeah, this one is very clear. Look at this. Right? You see those layers there. So this is where we say, you know, angular interlocking minerals that are in a pattern. This is the pattern, that banding striped pattern. Okay? Another good example of banding. If you were to look at the, what else do I have? This was in that one homework. If I was to take the banded rock that we saw in the homework, and hopefully you should remember this from that homework. Okay, you see it here. You can kind of see some of the band right here, the layering or grouping together. You kind of see it right here. Banded rock. Nice. That's the name of that rock, nice. So, and we colored that green. So now we're on number 6. And it says, the high temperatures and extreme pressure a metamorphic rock experiences causes chemical reactions to occur within the rock. These chemical reactions cause many minerals to transform into mica. And it says micas are the thin, flaky mineral. Remember those? Therefore, metamorphic rocks often contain a high concentration of mica minerals. It has to be high concentration, like a lot of it is mica, 60% mica, 70% mica, not just a little bit. Most rocks have a little bit. Draw a blue star next to the rock name of the metamorphic rock that has platy mica crystals visible. And we're doing a blue star. A blue star. A blue star, here we go. Platy mica crystals visible. Right here, platy mica crystals visible. I'm drawing a blue star next to the name. and it is schist. The name of that rock is schist. And let me show you what I mean by platy mica crystals visible. But the key thing transforms into mica. That is a key metamorphic mineral. Here we go. Oh boy, you really can see it here. Here, I don't know how well this comes across, but you see this shiny. It's very shiny. Those are all flat layers, and if you can see, these mica minerals all run this way. That's why it looks so shiny. Their flat surfaces reflecting it. I don't know if you can see some of the there's like banding in here with the dark layers being in the foliation. So pressure was this way, and they're all flattened like this, and you see this side too. It's really super shiny. And the platy mica crystals, you can see the individual crystals. Again, if you were here, you could see it more, but I can go like this with my pen. Oh, I don't want to get red pen on there, but see the flaky mica pieces, I don't know how well it reflects in the light maybe, came off on the paper, maybe, hopefully it's shiny. Oh yeah, it's shining back a little bit. You can see that. Yeah, it looks like glitter, not glitter. Okay, those are flaky, platy mica crystals that broke off, so that's cool. What else we got? Find the metamorphic rock that has a parent rock of limestone dolostone. Draw a blue box around the rock name. You got to look here. You got to look around. Comments. Metamorphism of limestone dolostone. That means that's the parent rock, and it became marble. Draw a blue box. There you go. Name the parent rock of slate. Slate is here. Low-grade metamorphism of shale. So the parent rock of that is shale for number 8. Shale. And what are the 2 types of metamorphism shown in the chart? See types of metamorphism column. So, type. There's regional metamorphism. That means it happens over a large region, a big area, and regional again. And then you have contact, which means contact with heat. Oh, my rocks just fell. Like lava, magma. And then this is regional or contact. So there's 2 types, and it is... now, I messed up my pen with that before. So, regional... and contact metamorphism. Okay, again, contact is usually contact with lava that kind of like cooks it. Alright, so those are some of the key things for metamorphic rocks for us to start. 101, be ready for the quiz. Know this stuff. Thanks for watching. Mr. Gazda, signing off.